There's a pattern that's easy to miss if you're only watching DeFi from the front end. The yield platforms, the trading interfaces, the wallets, all of that is the surface. What's happening underneath has quietly started to look different. DeFi protocols are beginning to function as infrastructure rather than as consumer products. They're running as backends behind applications that don't advertise their underlying stack. Today, I want to map out what that shift actually means, and why the protocols positioned for it are the ones worth paying attention to. Let me start with traditional finance, because the analogy is direct. When you tap your card at a coffee shop, you don't think about ACH rails, correspondent banking, or card network settlement. You tap. The money moves. The infrastructure behind it is invisible by design, not because it's simple, but because it works well enough that no one needs to see it. The consumer product is the relationship. The infrastructure is the plumbing. DeFi's first decade didn't look like that. Yield percentages in huge numbers on the homepage, wallet addresses instead of account names, protocols that required users to understand gas, slippage, and private key custody before they could do anything. The infrastructure and the product were the same surface. You couldn't use the product without bumping into the infrastructure. That model isn't going away, but something different is starting to appear alongside it. Blend money is the clearest reference point. Yield products inside neobank interfaces, backed by DeFi protocols on the backend, presented to users as an interest account. The user experience is familiar. The settlement layer is on-chain. Most users will never know the distinction, and that's not an accident. That's the architecture working correctly. This is what I mean by infrastructure phase DeFi. Protocols that are useful precisely because they can disappear behind the products built on top of them. Now, what actually makes a protocol suitable for that role? It's not marketing. It's a specific set of architectural properties. First, deterministic execution. Infrastructure has to behave consistently across conditions. A protocol whose execution quality depends on external capital, LPs depositing and withdrawing, market makers adjusting depth, introduces behavioral uncertainty that makes it unreliable as a backend. When conditions deteriorate, LP capital withdraws, rationally, from each LP's perspective. But a product that embedded its execution on top of that system now has a reliability problem exactly when its users need execution most. A protocol governed by on-chain parameters rather than external capital dynamics has a different property. Its behavior is predictable. That predictability is what makes it usable as a dependency, not just as a product. Second, API accessibility. Consumer-facing DeFi is designed for humans, buttons, confirmations, visual feedback. Infrastructure-facing DeFi needs a different interaction model. The counterparty is a system, not a person. That means clean programmatic interfaces, predictable state transitions, execution logic that can be read by code without interpretation. Documentation matters here as much as the smart contract design. Third, composable risk management. The products built on infrastructure need to understand the risks they're absorbing from the layer below. A protocol where risk parameters are on-chain, auditable, and stable gives builders something to reason about. One where risk is distributed across LP behavior, governance votes, and opaque backstop mechanisms is harder to build on, because the risk profile of the underlying layer can change in ways that propagate upstream. These are infrastructure properties. They show up in how a protocol was designed, not in how it describes itself. So where does LeverUp fit in this picture? LeverUp's protocol-managed virtual liquidity architecture addresses the external capital dependency directly. Execution capacity is governed by protocol risk parameters, not by the size of an externally supplied LP pool. A product embedding LeverUp's execution layer isn't building on top of behavioral capital. The settlement layer doesn't make decisions, it runs. AnyCollateral extends the composability surface, a protocol that handles collateral in its original form without requiring conversion to a single base asset, can interface with diverse capital structures of embedding applications. An app managing user portfolios across multiple assets can route execution without forcing users through a conversion step first. Pyth Pro Oracle pricing removes another source of uncertainty. Because execution pricing reflects Oracle feeds rather than curve state, the behavior of the execution layer is legible from the outside. The inputs are observable, the pricing model is consistent, the outputs follow from them. None of these were selected because someone had an infrastructure ambition on the roadmap. They're the natural consequence of designing a system that doesn't require external capital to run. The infrastructure readiness is a byproduct of the architecture. But I want to be direct about what's still ahead, because this is where a lot of thesis pieces lose me. Having the right properties isn't enough. The infrastructure layer requires the ecosystem to actually build on top. That path runs through integrations, wallet developers, DeFi frontends, AI agent frameworks that need reliable execution infrastructure. These don't emerge automatically from good architecture. They require API documentation, developer tooling, integration support, and reference implementations that reduce the friction of building on top. The protocol has to become legible not just to traders using the interface, but to engineers treating it as a dependency. That translation work is what's still in progress. But here's the thing about infrastructure patterns in financial systems. The protocols that matter most to end users over the next decade may not be the ones users know by name. They'll be the ones embedded deep enough in the stack that users never need to know the name at all. The question worth watching isn't which protocol has the best interface. It's which protocols are getting integrated as backends, quietly, by builders who have decided they can depend on them. For the broader architecture behind this thesis, the LeverUp as Financial Execution Layer article is the companion read. Link is in the show notes. As always, this isn't financial advice. See you in the next one.